All right, you guys, last page. You're almost there. This one says calculate the value of x right here. So first of all, this is just a couple of different things here. If we look over here at this angle 126, I know that this angle must be the rest of 126 to get to 180. So I have 180 minus 126 is going to be 54. So this is going to be 54 degrees because 54 and 126 is 180, and these two angles are supplementary. And then my inside of the triangle needs to be 180 also, so 58 plus 54 plus some number, we'll call it, well, I don't want to call it x because the other one's x, plus some number y is equal to 180. So 50 and 50 is 108, 9, 10, 11, 12, so 112 plus y equals 180 minus 112 on each side. And y is equal to 180 minus 180, and 80 minus 12 is 68. So this is 68. So does that work? Let's double check in the calculator. Is 58 plus 54 plus 68, 180. Nice, my mental math worked. And that means that 68 plus x have to be 180 also, so I can just say 180 minus 68 is equal to 112. So x is 112. So you can do it the long way, kind of like I did. Or if you realized the shortcut, always, always, always in triangles, what's going to happen is that this angle plus this angle is going to be equal to this outside angle here. But sometimes that's hard to remember, so you can always do it the long way like I did. So what's next? What's next is shifting and dilating. So I'm not sure if I caught everybody, but in this particular case, you need to dilate first. So I will show you what happens here. Let's plot our original one. We have A is 0, 0. B is 1, 2, 3, and up 1, 2, 3, 4. And C is 3, 0. So there's our first triangle, and we call that A, B, C. And the reason we have to dilate it first is because this original point is at 0, 0, so that's not going to move when I multiply each side by 2, right? 0, 0 is going to stay 0, 0. That's going to be A. B, on the other hand, was 3, 4, and it becomes 6, 8. So I need to go over 3 more and up 1, 2, 3, 4 more. So this is my new point here. And C just is going to double here. So this is 1, 2, here. So my new triangle is this one here, right? Now I can do my shifting, and I think you'll realize you might get different, in fact, I know you will get different numbers if you don't dilate first. Okay, so let's shift. Each one is going to be shifted up 4, 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So here's my new A from the bigger triangle, right? And here, whoop, this isn't going to fit, and I think somebody in the other class let me know this. So if this, what we will do is we will show you it's going to be this like kind of big triangle here, I think, but since it's not going to fit on our numbers, let's just write what the new points will be, right? So if we shift A up 4 and over 6, what we get is -6 is the x, and we are up +4, right? If we shift B prime, and remember we're shifting the primes, right? So B prime is up here. So shifted, my new totally shifted here, A prime is at negative 6, 4. Now we need to shift this b, and it's already at 6, 8 right here. So if we shift it up 4, that 8 is going to become a 12. Remember, y is my rise. And if we shift it left 6, that 6 is going to be 0. So let's see if that does, yeah, it won't fit, but it will be like at the 0 here. And then c will be here. So this is what it's actually going to look like. And c prime is going to be my brand new one. So here, when we doubled it, this became 6, 0. So when we moved it up 4, our y became 4 instead of 0. And when we moved it over 6 to the left 6, our positive 6 became 0. There. So these should be the coordinates of the new triangle. And it should look something like, even though it's off the charts over here, even though it's off the charts over here, I can still show you it'll kind of still be, my A and my C will be there, but it's my B that's like way up there, way up at the top. Ha! It's gonna kind of look like this, but of course, much, much better. Okay, and then, gosh, do we only have one more question? Yay! And this is exactly from your last interim test. So part A, are the two figures above similar? If so, describe the series of rigid transformations and dilations. And map figure 1, the regular ABC, so that's the smaller one, to figure 2, A prime, B prime, A double prime, B double prime, C double prime. So the question is, what am I doing to ABC? And this was on the test. I think everybody did really well on this, to change it into A double prime, B double prime, C double prime here. And so what are my rigid transformations? And if that is happening, that means they are similar. If I can transform one into the other, that means they are similar. So that's kind of why I wanted to revisit this question here. So I think that's weird. Does that look like two different colors? My eyes are going a little bit crazy. Okay, so I think what a lot of you did, the first thing you did is you rotated this triangle by 180 degrees. And what that did is it put it here. If you rotated it 180 degrees, it lined up your B's. But remember, to get from B to A was just 1. And then your C was here. So when you did that, you ended up, if you rotated 180 degrees, and it doesn't matter if it's clockwise or counterclockwise, right? You have rotated this way. Then you get, here's your little triangle on top of your old triangle. And then we have to figure out, okay, how are we dilating? What are we making it bigger? And what you realize is the original BC was just 2 blocks, right? 1, 2. The new BC is 1, 2, 3, 4, 5, 6. So it was 2, it's now 6. 2 times 3 is 6. So we know if we multiply the BC side by 3, we get 6, but we don't know if that works for every side yet, so we still haven't kind of figured out if they're similar. So let's look at AB, right? Let's look at this side AB. It was originally just 1 block, right? This purple triangle, but now it is, that's 1, 2, 3. So if it was originally 1 block, I need to multiply it by 3 blocks to get to 3. So again, that side's 3 times bigger. And then let's just double check. I think we do have to have all of the sides to figure, oh no, we have it because we have 2 sides and we know that this angle is 90 degrees. So we technically have similarity properties by the side angle side theorem of similarity. But just for kicks, here we have a slope of 1 over 2, right? And in our big triangle, so that was the slope there is 1 over 2. In our big triangle, we have up 3 over 6. And when I take 1 divided by 2, I get 0.5. And guess what? When I take 3 and divide it by 6, I also get 0.5. So if they have the same ratio, then when you multiply it by 3, you're going to get the same side length. We just can't figure it out now because it's catty corner, right? We just can't count it up. All right, you guys, so good luck studying. I look forward to seeing you tomorrow with completed test reviews. You must have a completed test review to take the test. Otherwise, you will have a 0 until you are able to complete the review, and then you can come take the test. And that way there's no penalty and there's no having to take the test twice. But I need you to be prepared for this. So good luck, and I will see you tomorrow.